Alright guys, we're going to go through this final example. So it says, number 1, UC Davis has made a claim that the average cost for reconstructive knee surgery is less than $8,000. You decide to investigate, and after getting a sample of 16 knee surgery costs, you find the average to actually be $7,723 with a population standard deviation of 2,629. If we assume this data is normally distributed with an alpha level of 10%, can we support this claim made by UC Davis? So what we're going to do for this one is I'm going to start by going over all the different rules and all the different steps for solving. So the first step is to write out your hypotheses mathematically. Then we're going to circle our claim. We're going to decide if the tail is left, right, or two-tailed, then draw the curve. We're going to find your alpha level's z-score, place it on the curve, and shade that rejection zone. And we're going to find your sample statistic, place it on the curve as well. Once you place it on the curve, you're going to find out, is your sample in the rejection zone, or is it outside of the rejection zone? Then finally, we're going to analyze it with a write-up. So let's start by writing out our hypotheses mathematically. Now we're going to find our hypotheses in the claim. It says the claim that the average cost for reconstructive knee surgery is less than $8,000. So less than should be the thing that really kind of stands out here. So let's make it red so it does stand out. Less than is a form of inequality. Inequality always go in the alternative hypothesis. If it said at least or at most $8,000, that would be a null hypothesis. But because it only says less than, it is our alternative. So let's write it out. Mu is less than $8,000. Okay, so alternative mu is less than $8,000. All right, next what we're going to do is we're going to write our null. Remember, our null just takes whatever symbol we have in our alternative and flips it and puts a line under it. Or if you only have the null, it's going to flip it and remove the line from it to become the alternative. So mu is greater than or equal to $8,000. All right, well, I can't really draw a circle with Google Docs, so instead we're just going to highlight it. We're going to highlight this whole alternative hypothesis because this is our claim. Let's try that again. This is our claim. There we go. All right, so our null hypothesis is listed. Our alternative hypothesis is circled, or in this case highlighted, so we have now gone through steps 1 and 2. Well, now we need to decide if it is a left tail, right tail, or two-tail test, and then we're going to draw it on the curve. So if we look at our alternative, because we will always stare at our alternative to figure out what type of test we are dealing with. In this case, you can see a less than. And if you ever draw a line down the middle of a less than sign, it's going to turn into a left pointing arrow. So imagine that this is pointing to the left because it's a left-tailed test. If it were greater than, it would be a right-tailed test, and if it said does not equal, it would be a two-tailed test. In this case, it is a left-tailed test. So now we're going to decide if it is left-tailed, which we did, then draw the curve. Well, I already started making a curve on our presentation, and we're going to take this line and put it where it belongs. So this line is either going to make a left or right-tailed test. We said it was going to be left, so let's put the line right around here. Now what we need to do is find 10% on our z-chart. So let's go ahead and we know that 10% is less than 50%. Because we know this, we're going to use our negative z-chart, which I have right here. So we're looking for 10%, and I think the closest we get is right over here at about 0.1003. And I can actually, I think, zoom in a bit to make that a little bit easier to see. So right around here at about 10%. So we look and it has negative 1.2. We're going to follow it all the way up and find it to be 8. So negative 1.28 is going to be the z-score for our alpha level. Okay, so we will say our alpha z-score is equal to negative 1.28. And that's going to be very important later. And we'll get rid of that highlighting. All right, now that we know this, we can actually put that on our curve. So let's go ahead and do that. And let's call this curve right here 1.28 is our rejection zone. And that's where our rejection zone begins, at negative 1.28. All right, so now what we need to do is find out if our sample statistic is going to be in our rejection zone. Remember, our rejection zone is to the left, so it's on this tail over here. If our sample statistic ends up in here, we can reject our null hypothesis. If it ends up outside, we will be unable to reject our null hypothesis. So let's crunch the numbers needed. All right, remember, our equation is going to be z equals x bar minus mu all over standard error. That is way small, so we'll go ahead and make it nice and big for you guys. All right, so what we need to do now is find our x bar, our mu, and our standard error. Well, we said that x bar is our sample average, and our sample average that we collected was 7723. So 7723. We're going to subtract from that our mu. Remember, the mu is what we get in our claim, which is 8,000. We're going to divide that all by our standard error, which is standard deviation divided by the square root of n. So our standard deviation is going to be 2629. We're going to divide that by the square root of our n, which is 16. So that's the square root of 16, which is just 4. Let's find out what this equals. So on top we have 7723 minus 8,000, which is 277. And below that we're going to have 2629 divided by 4. Well, 2629 divided by 4 gives us 657.25. All right, now we need to divide these. So 277 divided by 657.25 gives us 0.42. And this is our sample statistic, or our z-score. It is actually negative. All right, we now have our sample statistic. So we found our sample statistic, and now we need to place it on the curve as well. So let's go ahead and do that. All right, I think we can all agree that negative 0.42 is less negative than negative 1.28. So it's going to be, let's say, somewhere around here. Now the placement on here doesn't really matter so long as you get it on the right side. So let's call this negative 0.42. And I think we can all agree that it is outside of the rejection zone. So looking at these two, we can see it is outside of the rejection zone. So let's go ahead and go back to our steps and see what that means. So is your sample in the rejection zone? No, it is not. So we can go ahead and skip A. Let's look at B. Is your sample outside of the rejection zone? Yes. So we will do not reject our null hypothesis, and do not support your alternative. So we're not going to reject the null and we're not going to support the alternative. So let's now go back to what those were. All right, so we said that we are not going to reject our null and we're not going to accept or support our alternative. Well, since our claim is the alternative and we cannot support the claim, let's write that out. We cannot support the claim. All right, let's throw everything together now and write out our analysis. We'll actually make it a bit smaller because this is a very large font. With an alpha level of 10%, we cannot support the claim that the average microfracture knee surgery is less than $8,000. That's it. So this may seem counterintuitive because we did find that in our sample of 16 that they were in fact less than the 8,000 claimed. Unfortunately, these numbers are so close together, they're so near to each other, that it does not mean that all of the microfracture knee surgeries will end up being under $8,000 as an average. Now, if this number were closer to 6,000 or 5,000, that would probably be enough evidence to support this claim, but because these numbers are so close, it was not enough. All right, guys, thanks for watching.